Our final speaker is Javier Glatt, co-founder and CEO of CAD Makers, Inc. CAD Makers is a recent startup that focuses on applying manufacturing processes and technology to the construction industry, including virtual construction, automation, tool building, and prefabrication. So far, they've provided services to more than 60 projects that have a total construction value of more than $6 billion. Javier?
So I understand that I'm getting pretty close to being the only thing stopping you from lunch. So I'll try to be very, very quick. I'm just going to hammer through. I got a ton of stuff I'm trying to get through in a short period of time. I may or may not make it. If I go too fast, like a maniac, just grab me after. I'd love to jam with you and chat. First, I just want to take a quick step back and say, it's incredibly honoring. I'm honored to be here today. 2.5 years ago, almost to the day, my business partner Nick and I were sitting in a storage locker. It had smashed windows and a padlock on the door, and we were trying to figure out what the heck we were going to do to try to, help solve some problems in the whole construction value chain, and also maybe find a way to feed ourselves in the meantime. So just being here and you giving me your time, your valuable time, I'm tremendously honored for that. And I'm going to do my best to give some value, hopefully, today. So let's jump right into it. So the way to describe our company and our relationship with Dassault Systèmes, we're a customer and a partner. We're very unique that way. Dassault Systèmes we like to think of as the science. You have this extremely powerful engine that if with some creativity and some smarts, you can make that thing dance. It really is an amazing platform with a lot of functionality. And then we like to think ourselves as the applied science. We're really understanding at the grassroots level what the problem in the market we're really trying to solve is, like really what the problem is, and then finding ways to solve it using technology. And for us, it's a big deal to do it that way and in that direction. We're not romantic about software. We're here to drive value to the market and move the needle. And technology is just an enabler to make that happen. So today, actually, maybe one more part of this. What we've learned, the truth of 2.5 years ago, we didn't think this was going to happen. But this is what we do today. We do services for projects. We learn at scale. And then we develop use cases and build automation tools ourselves to solve those problems. So it's kind of a circle. So we do projects, we learn, we build automation tools, solve problem, and then incrementally get better each time, both for ourselves and then also for customers and people we work with. So today I'm going to talk about 4 stories, and they're completely different. The first one's going to be applying a really kind of sophisticated modeling and technology to a low-tech industry with Charter & Morton Mechanical. We're on a wastewater treatment plant, not typically looked at as high-tech. But we're going to talk about working with individuals that don't even use computers. And due to process, it's not really set up to collaborate. It's not really set up to be optimized. And we're trying to hack that and find an optimized workflow to deliver a result for this customer. The next, I'm going to talk about a really forward-thinking property developer that's looking at new materials as a new way to potentially change the entire construction industry through mass timber, which we're heavily involved with, the world's tallest mass timber building. The next is kind of really 2 stories of the same coin, 2 sides of the same coin. The first is with Westbank Icon, one of our great customers of ours. They're a vertically integrated developer. We're going to talk more about the upfront planning, data-driven decision-making, and optimization for complicated facades. And then the next step, I'm going to go to our work with contract glazers, taking kind of the back end of that and saying a really optimized workflow to do the actual fabrication from beginning to end. So it's kind of two sides of one coin. So the first is a wastewater treatment plant. It's not typically, you want to look on the inside of these types of buildings. It's very much, you don't want to go in there if you don't have to. But what we're trying to do here is take a process where it's design, bid, build, which means the design is actually disconnected with the individuals that will build it. That's a different discussion for a different presentation. But it's set up with gaps. And it's not really set up to be done well. And what we're doing is found a way to sit with the contractor that has 30 years of experience, that has forgotten more than we would ever know about wastewater treatment plants, but digitizing that knowledge, capturing that knowledge, and delivering prefabrication output that can ultimately do more with less inputs. So really the goal, the value proposition here is labor risk. How can we budget this with 20 people? Can we deliver the project with 4 or 5? Because you're prefabricating, you're coating pipes off-site, you're spooling pipes off-site, you're just delivering only the exact kit of parts required for assembly, and then just putting it together rapidly, right? And doing that in a digital environment. So here we're showing us just like a reducing coupling, and it's all on the 3DEXPERIENCE platform on cloud. It's CATIA on cloud. We're linking that to all the information we use to build this assembly. We're taking other parts from a database that's on the cloud and reusing this as a huge valve. It's hard to see in this context, but that valve is so big, or that it has to be craned into position. It's like 1,000 pounds. So you have to actually nail this geometric dimensioning and tolerancing. For the manufacturing people in here know this. In construction, that's a term that no one talks about. But in a case like this, you really have to get to that level of detail because you have to optimize the assembly process on site. So it's hard to see here, but if you see that guy's arm like this, that's the foreman of the project. He's 35 years, a veteran. He doesn't use computers. He actually mailed us all his drawings with red ink to communicate with us. And here he is using a Wi-Fi connection, using CATIA on the cloud, and collaborating on site in real time to optimize the assembly process. So, Monica talked a lot about experiences. I don't want to get too dramatic with it, but the experience for this individual is let him do what he's good at, which is understanding what happens on site, and let us our engineers work closely with him to optimize that process and deliver an outcome that's obviously drives a lot of value for them. And then, one thing everyone talks about 3D, but still in the fabrication world, in the construction industry, by having a cut sheet, an automated BOM, bill of materials, and lengths, it reduces the barrier of entry in terms of the fabrication shops they can use. If we can give information that's really easy to understand, just about anyone can cut that pipe and coat that pipe and weld that pipe off-site. So this is kind of a true digital representation of the 3D, cut it back down for fabrication drawings, and as you can see, it's like bang on in terms of what's built. So this is kind of our lean construction slide here. It's a true digital representation of what's being built, which is typically done in a 2D environment, single line diagrams actually, like an isogen type view. So I'll summarize this again at the end. Different project here. Okay, so the next one. Okay, so let's move over to the world's tallest mass timber building, which was we were a big part of from design through it's currently happening using CATIA, Delmia, 3DEXPERIENCE on the cloud. The first step here was because when the project, first of all, the code only goes to like 6 floors. This is 18 floors. So the first goal for this was to use a digital environment to go to the code professionals and prove to them that this is actually doable. The engineering, the calcs can be run, you could prove it, but it's never been done before. So the first step here was a digital mock-up, which people in the construction industry don't know much about, but of course the aerospace and manufacturing people here would understand that. But this is a Delmia digital mock-up showing 16 different connection points being tested prior to we'd even built this mock-up. And building the mock-up live was helpful. You did a lot of supply chain stuff. But right in the room while we did this, before we started, the builder already knew which connection detail he liked. He liked the center tube, it kind of acts as a natural leveler, and brought it in. And just this is, one day I think in construction we'll get to that we can save a lot of money. It's a lot more cost effective to simulate the entire process on a computer screen than build things live. But we're not quite there yet, but I think this is the future that we see, is doing as much as you possibly can on a computer screen. So once we did the mock-up, it was 60% faster than a traditional build of a concrete building of the same size. They said, okay, we get approval. We think this is right. It's all about speed. It's like a giant manufacturing project. Think about it. It's all about speed. So this is the full assembly of the structure. So every single nut and bolt, every screw is in the model. And why is every screw in the model at spec level? Because the screws are like mass timber screws that were coming from Germany, like $2 a screw. So from a cost perspective, it was a risk. So we had to capture all that in the fully integrated structural model that was for fabrication, and then all the MEP and every other part of the building was also in one central model. Bernard talked about a single source of truth. We figured out a process in this project where everyone fed us data, sometimes hand sketches, something really easy for them. We maintained one fully integrated fabrication model for the entire building systems that everyone could benefit throughout the project, which proved to be very effective. So there's the first floor, extremely busy, different concept for construction. Again, aerospace, they do this. This is why we recruit people from aerospace. You start with the as-built. In construction, they build design. typically. So as they're building, they're changing things. In this case, we said, this is the as-built. Before you start, this is the finish. Everyone follows it, and everyone did on the project, which proved to be good. The transfer slab rebar, we had to model so we used power copies and scripts for this to be able to do this quickly and ensure that all the mechanical rising, all the penetrations coming for the rebar were actually going to work. And the reason we did this from a business perspective is you have an 18-story wood frame building. The structural engineer doesn't want you cutting slab bands and bars in their transfer slab because they don't want this thing to fall over. So this level of planning and detail doesn't typically happen in a construction project, but in this case, it made a lot of sense. Going up, we had to detail every floor, every stud, because we're giving all the fabrication data directly from the CATIA model for the project. And then this is the encapsulation layer. Because it's an 18-story mass timber building, there's obviously a lot of risk around fire. So we wanted to communicate that we're meeting all the site-specific regulations with regards to fire on the project and showing the drywall gyp that was encapsulating the wood to make sure that the project got approved. There's a typical floor. So one story I want to tell about our thesis on automation and why we like CATIA so this, if you can see all these studs, the first time we did this, we were learning, we drew every profile of every stud manually, and then we did a little power copy because some stuff was repetitious, and it took like a week. So 40 labor hours. After that, we said, we're never going to do that again. We created a UDF in the software, user-defined feature. We took the same output with this single UDF, which was a line as an input, where you do one line at a time. Took the week to 2 days. So we could now do 1 week of our cost in 2 days. And then we said, okay, that's not good enough, and just recently developed a multi-instantiation UDF for a user-defined feature that batches all the walls at once and creates all the geometry at once, and now we can do that exact output in 20 minutes. So we took work that we typically took 5 days to do, that now we can do in 20 minutes, just by using automation tools on top of CATIA. So all the wood went directly to a CNC machine for fabrication. So again, it's a giant manufacturing project, but for a building. On the left there, that's actually, we wrote a script in CATIA EKL to calculate the center of gravity of every panel. And why is that important? We had 40 different panel types. And when the truck, it comes off, actually, maybe I'll just keep going. When it comes off the truck, we want to make sure that you rig the panel perfectly so that the panel comes up exactly flat, they fly it in exactly flat, and they get the next one. If each time you're trying to calculate where the panel is going to be, if the panel comes off like this, if you can imagine, it just slows down the whole process, right? And everything was about speed. We actually used a 2D layout for 3D design and CATIA natural sketch to embed. So we gave a model, a step file for fabrication. They still, for legal reasons, had to generate shop drawings. So we took that back in, overlaid it on the model. As you can see, the precision of the geometry were to the 10th of a millimeter from our CATIA model, which is another reason why we like using the software. So once you had all these panels figured out, the other way it's like, okay, let's work with the plumber and optimize the plumbing stacks. Let's take that down to 2 typical groups. We optimized the bathroom groups to just 2 typical spools with the bill of materials and gave them this on site, and they're able to create, they just finished a project about the same size. They're doing the exact same output, 1 full mechanical floor per week with 30% the labor hours. So that's where I think when you use technology in a real way to drive value to the customer, it's quite powerful. So mechanical room is also another area where it's always good for prefab, because construction stuff is, if you look under this thing, there's pipes everywhere. So, and there's a lot of opportunities to prefab those pipes, but the challenge is you can't control the other elements. And when you're working in a construction environment, there's many different trades that need to coordinate. But a mechanical room is roughly 1 or 2 trades, and it's lots of complexity in a small area. So it's a great target for prefabrication. Here we're using Delmia on the cloud to be able to break down the master assembly of the mechanical room into each sub-assembly by system, and then ultimately to the part level, so that we can integrate exactly like a manufacturing bill of materials, make sure that you don't start this work before you have all the materials to build, all the fittings, all the hangers, and then breaking out the tile view for planning purposes. So to give you the numbers, that mechanical room typically takes 800 to 1,000 labor hours to build and stick build, which they typically send bulk material to site and then they stick build it, 800 to 1,000. We took about 160 hours of our time to detail a mechanical room, make sure it meets for all the specifications codes, and they're going to build it in about 160 hours. So we're looking at 320 hours versus 1,000. So we're talking big needle moving by using prefabrication for construction.
Next thing that came up, they said, we've never built 17 stories of core before, which is concrete core. And we used Dalmia to simulate. We sat with the team. Everyone, safety was factored in. They wanted to use cast in place landings, precast stairs, that we changed the way that it all comes together. And then finally, in 3 days, we turned around this simulation that took down every single step in the most optimized process over a 5-day cycle, 38 steps, and a 2-floor pour. So everyone contributed to this on the team when we were driving the computer, but everyone had their say that was at the table, like 15 different companies. And then we gave them this that they repeated, and they flew that core up unbelievably fast. And no one had ever seen it before, that had ever built a core like that. There you go, a true kind of digital representation of the built environment. Now, the last thing before I get out of here, this is the actual build. So mass timber is an interesting building material. What's interesting for the manufacturing people here is that you can really use prefabrication. And this building was built multiple times virtually before we built it once, and it's the first time it's ever been built. You would typically think there's an innovation tax or something that would slow you down. They built 17 stories of structure and envelope in 9 weeks, which is like a pretty incredible thing. And you can see on the left the simulation in Dalmia breaking down every single step of the way to the day, every activity that needs to happen in each of those days. And again, the collaboration of the experience of this was that everyone was at the table. The builders were at the table, the general contractors were at the table, the architects at the table, and everyone's working off one model to pre-plan and do it right once, which is a big change from what they typically do. I'm going to just move forward. If anyone wants to see this, I can show it to you later. This is across the street, same client. I just wanted to show this because I'm sure there's a few nerds in the room. So we had a situation where a bus terminal right across the street, they needed to simulate the sweat path of buses, making sure that 3 buses would fit in each bay. And there's transportation softwares that are expensive for this kind of one-off situation. So using CATIA EKL and kinematics, we had one of our guys just spent 2 days and wrote this script where it allows the user to draw any swept path that they want, and then the tool through computation will calculate where the rear axle needs to be. So then for a bus, it has its own rear axle calc. We're doing right now one for a limo, and we're kind of building a database of different vehicles. And then you can very rapidly, like it's took 2 days as opposed to what they were really going to look at, you can simulate exactly where everything's going to be moving based on the kinematic mechanism player. So I thought that was just kind of neat. So next, let's talk about data-driven decision making. So this is I've just come to realize that numerical analysis is not a spectator sport. So this video is terrible. So I'm going to talk to you about it while it's happening. So pretty soon you're going to see a green line on top of that yellow line. Here's the use case. So we're working on this project. This happened right now, actually. This is like from 2 days ago. So it's dual radius curve of glass for the windows, dual radius curve for the extrusions required for the bottom sill and the top sill of the glass. And then you have precast concrete that needs to connect to this. To add even more complexity, the extrusions, because dual radius aluminum extrusion is not easy to do, and there's not many people in the world that can even do it, from what I understand. So that's being done in China. And then there's the glass is being done in another country overseas, and the concrete's being done in North America. So it's a big risk to be able to get all this to work together in the project. So in this case, we're dabbling with numerical analysis to write the most optimized geometry to minimize the number of molds needed. Because that was identified as the biggest risk is the mold. That's what's most expensive and where the most things that can go wrong. Once we optimized, originally there were 50 different molds you would need for 2 floors. We're trying to get to 20. So we're using numerical analysis to run thousands and thousands of iterations and computations to find the most optimized process, and then allow the computer to tell us, okay, this is what the geometry should be, and then we can make the concrete change to fit. So there you go. That green line is what CATIA has basically said. If you change it to this, you can optimize it's the most optimized layout in terms of the extrusion. Okay, so once you do activities like this to optimize, I'm running out of time here. Okay, so once you do that kind of optimization study, the next thing we need to do is they used to go out to the market and say, okay, I got this facade. And tell me how much, they get drawings, 2D drawings, they throw it out to multiple fabricators. Tell me how much this facade costs. But what was happening is they're getting surprises, things were changed. It wasn't necessarily an optimized end product. So what we started doing with them is say, okay, before you go out to the market, give us the conceptual drawings. We're going to use C# and CATIA EQL to write a script that can create, in this case, 2,020 unique, total panels and slab edge anchors, as you can see, automatically. And then very quickly we can, I'm going to go really fast, once we have the geometry, we can actually export it to Power BI and do really interesting power pivot to say, okay, instead of saying, tell me how it is, you tell the market, okay, I have 273 unique panels. This is exactly the square footage panels. This is how many balcony panels I have. This is how many vertical face panels I have. This is how much structural glazing I have, because they're each systems and typically different people that do it. And then you have a situation where you have a flattened view that can help. I'm just like the red number over there is killing me. So, and then the real value is now you can actually do constructability analysis, find issues before you have. In this case, we modeled the PT cable with all the embeds to make sure that's all going to work. And then when you do it right once. Last, this one I'll just let it run, and then I'll tell someone the music will come on and they'll kick me off here. But this is on the facade fabrication side, and this is pretty neat, I think. They came to us and said, okay, we have a legacy SQL system that's our ERP system. We're going to deploy CATIA 3DEXPERIENCE on the cloud, and we're going to use that for the modeling side of things. And we had to find a way to bidirectionally connect CATIA 3DEXPERIENCE on the cloud with their SQL system. So we use C# and SQL to connect that. And then we can do a lot of really interesting things. So we started implementing Power BI on top, so at any moment you have a live view into all the data. So what's been cut, the data, how many parts are going to the CNC machine at any given time, as you can see here. So this is the visualization of all the different parameters. And then we're doing things like a script to batch all the parts for procurement that are needed to be bought. We're batching it all instead of in Excel summing them all. It's all coming directly from the data and it's integrated. And another thing, there's a lot of good stuff here. Stock length, that's what I was talking about. There's lots of good stuff in this video, so I'm just going to let go. But one key element to come back to the cloud. So 2 weeks ago, we're sitting in Vancouver, our coding team sitting there. This contract glazer says, hey, we have a sheet metal question, and we need you to help with this JavaScript that we're trying to do to get this browser-based viewer on the shop floor. So we're just sitting in Vancouver, we do our work. A couple of hours later, throw it up into their tenant cloud, and within like a couple minutes, they just in the cloud, bam, they have the code and they have the sheet metal part. So it's like completely changing the way that we can consume data, is using the cloud and connecting us with our customers in a way that's pretty powerful. And so we're very, very interested in that type of work. I'm sorry, I'm flying through here. Last thing. So we believe there's actually a thing in KnowledgeWare, it's called knowledge capture and reuse. We believe in capturing, digitizing, and scaling that knowledge through rules, through catalog components. Because for me as a business owner, I don't want to lose the value of the learning when I have someone work on a really interesting project. If we can capture that and capture as a rule or as a reusable tool, then it helps me scale. I can have 10 people, they didn't get work on that project, but they can get all the benefit of that learning from that one individual, and then we can apply that to the next incremental project. The next thing is if we can leverage collaborative processes and the tools within the platform and effectively try to turn every project into a manufacturing project, you can save a lot of time. That Tallwood project, here's some numbers. They originally planned to build it in 20 months. It's under construction right now. They're currently planning to be 4 months ahead of schedule. So opportunity cost of capital, they're about roughly $500,000 a month that asset generates. So that's money that you just don't get until you close off a project. Then there's also general conditions of a project, which is, of that project size, about $150,000 a month. So if you add up 4 times 150, what's that, 600,000, plus the opportunity cost of capital of $500,000 per month, plus if you have carrying costs on interest and construction financing, you can see what speed and time really means to the construction industry in that case. And I think hopefully it becomes a real case study for future projects. And then the last thing is this idea of data-driven decision-making, not just data-driven decision-making, but finding a business model where you can remove a lot of the burden to the veterans in the industry that feel they have to learn technology. You can figure out a business model, say, okay, let's take this data, let's take this knowledge, and let's combine the two, and then scale an outcome and an experience using the cloud, using CATIA, using Delmia. I think that's a real positive thing for the industry. So I'm way over my time. Thank you very much. I appreciate your time. Thank you.